Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you. In the previous video tutorial 99, we concluded, well, let me not say concluded, but we basically ended with our use of dedicated built up areas or urban area indices. Okay, so we've developed, or we estimated about, I think, 5 or 6 dedicated build up urban area indexes. Remember that article that I showed you guys, and that's where we worked from. Now, there's these 6 indexes which is supposed to identify and isolate and present build up or urban areas. That's pretty much what the focus of those indices are. But we clearly indicated that difficulty with those ones are that they struggle to differentiate between build up or urban areas on the one hand and bare soils on the other hand, specifically my region of interest. If your region of interest doesn't have that amount of bare soils, then obviously you're lucky and it won't be so much of an issue. But in my case, it's a huge issue. Okay, but there is many other indices that you can develop. So this video tutorial, we're going to spend a bit of time on those indices and see whether there's some potential in them, whether they can be used in partnership or in alignment with these build-up indexes to see whether there's some merits or some options there that potentially can lead us to what we want to achieve. So sorry, let me just hide this. So there's a couple that we're gonna go through. 1, 2, 3, 4, 5, 6. There's particularly 6 that we're gonna focus on. The first one that we're gonna do is what we call the normalized difference turbidity index. Okay, the normalized difference turbidity index. Okay, and let's have a look at the bands. It uses a green band. Okay, band 3, which is our green band, and then it uses the shortwave 1 band, which is band 11. So it uses green and shortwave infrared 1, those 2 bands it uses. And then it uses a normalized difference methodology or equation where you first subtract and then you add and you divide the 2 with one another. So it's shortwave infrared, subtract by the green band, divide by the shortwave plus the green band. Okay, so you have what we call the normalized difference, which is these 2, and then you divide to get to between a 1 and -1. We call it the NDTI, which is a normalized difference turbidity index. Very basic color scheme. Between -1 and 1, and very basic colors, gray, white, and blue, and then we present. And this is what it looks like. Now, the turbidity index is supposed to give you clarity of the water, how clear the water is. So it's supposed to focus on water areas, and then, as I said, give you indication of the water. So it's in theory, nothing to do with build-up or bare soils. It focuses on water, and this is what we get. Again, I'm not going to go through the optimization of my visualization in terms of getting the best minimum value, the best maximum value, and expanding on the color scheme. I'm not going to go. We spent lots and lots of time on that in our previous video tutorial. So this is just to show you that there is an index called this one, called the normalized difference turbidity index, and this is how you calculate it. And I said the idea of that is to give you about water. So let's quickly go to water bodies, which is the river. This is the Berg River, which runs from the Paarl to the Atlantic Ocean here by Veldhof, where I stay. And this is also home to the annual Berg River Canoe Marathon and all sorts of other water sports. So this is what it looks like. You can see it does indicate urban areas. So whether, as I said, it's not designed to do this, but it does look. And what I'm particularly looking at is whether it can differentiate between urban areas and bare soils. Remember, this is our bare soils here and the urban area here. So I'm looking at from a point of this issue of creating an index where we can differentiate between the two. So I'm not really interested in the water issues about this, although it does, you can see, it significantly identifies water. Okay. Now, obviously, if we can make this a different color scheme. So, in fact, the water should be blue. So if we use the inspector, we click on a water body. Okay, so we go to the normalized difference turbidity index. Let's go down it. I presume that value will be close to -1 or to the -1-ish area. There's a lot of them. You can see they're -6.4. So it looks, so that's why it's gray. Okay, so that actually should be blue. And then the white and this area here, let's have a look at bare soils here and see what that value looked like. But I think I don't want to spend too much time because I want to see if I can run for all of these indexes in one video. Because we most probably may use it. There we go, DTI 0.4. And let's have a look and see in urban areas. Now again, let's have a look and see if we can. I'm not sure if I use the inspector at the right place, but let's have a look. So the water is to the -1-ish side, and the bare soils is to the +1-ish side. We've used at the urban area. The urban area is around the 0. So potentially we can then use our thresholds to isolate urban areas. Anyway, something to explore in the next video, just to give you an indication. Okay, but anyway, so as I said, I'm not looking at this index for what its purpose is. Its purpose has got nothing to do with bare soils or urban or build-up areas. Its purpose is water and clarity of water and things like this. But that's not what I'm interested in. I'm looking at the other side. So that's what I'm using it. And it does seem like there may be maybe something to it. Okay, there may be something to it. Anyway, let's go to the next one. I just want to quickly have a look. Let's go to the next one. The next one is called the let's go over there. The next one is called the Soil Adjusted Vegetation Index. The Soil Adjusted Vegetation Index. Okay, so that's what the next one is all about, called the Soil Adjusted Vegetation Index. In this case, this specific index uses the red band and the near infrared band. The red band and the near infrared band. Now, if we go to the NDVI, which were let's call it the granddaddy of vegetation indexes, the one that that everybody used to, with Bear, where all these other indexes has been derived from. Okay, so the one that were there first, as in the Highlander, the movie, there can only be one. Anyway, so let's have a look at the NDVI. So as I said, that was the granddaddy of this index. Come on. That was the granddaddy of these indexes. And let's see what it uses. There's the normalized difference. And you see it loses near infrared and red. Okay, so it uses band 4 and band 8. Band 4 and band 8, which is red and near infrared. So let's have a look at its significant other half. It's one of its derived indexes. Let's have a look. Where is it now? Okay, so again, red and near infrared, 8 and 4. So it uses exactly the same bands, but where the difference lies in the equation, in the formula. So where the NDVI is a normalized difference, meaning you subtract and you divide by the addition, here the formula looks quite different. You've got the subtract part, that then you multiply by 1 plus 5, which you divide then by the near plus the red plus it, and then you multiply by 1.5. So this is a much more, call it, sophisticated equation, than just the normalized difference equation. So this brings this L, which is this 0.5 factor. It adds that factor, and then it adds this 1 and so forth. Okay, this 1.5 multiplied by 1 plus L, which is also 1.5. So it is a spin-off. It is an evolution of the normal NDVI. As I said, it just uses a different equation, but the same bands. Okay, again, a very simple visualization parameters, and then we display it. See how that looks. Okay, and that's the way it looks. That's the way it looks. Okay, that's the way that the soil adjusted vegetation index, okay, the soil adjusted vegetation index look like. Again, my first impression, if you look at the urban areas, you look at the bare soil, not a lot of difference between them, very similar. So whether this can efficiently distinguish between bare soils and build-up areas, I don't think so. It looks, very similar to the NDVI. So let's quickly have a look and see the NDVI, just as a comparison, NDVI, and see how that looks. Okay, just to see whether there's actually difference between the two. Let's have a look and see. For whatever reason, my NDVI does not want to display. Why is my NDVI not want to display? Anyway, we can come back to it. Let's leave it open and see what happens. Oh, it won't display because that's okay. Sorry. There's my look. Yeah, okay. But we've played around with the NDVI. We've manipulated and changed it quite a bit, so it's very difficult to display it. We should actually use exactly the same color scheme. We should actually use exactly the same color scheme as the NDVI, so that we can add. But yeah, so to see whether it actually, soil adjusted vegetation, whether there's big differences. Because we're not comparing visually we're not comparing the two properly. Okay, this is called the soil adjusted vegetation index. The soil adjusted vegetation index. NDVI evolved by using a more sophisticated formula. Let's have a look at the next one. Green chlorophyll index. Green chlorophyll index. That's how that looks. Let's have a look and see. Sorry, let me take this off. That's the green chlorophyll index. Green chlorophyll index. Let's have a look. We use the green band and the red band. And then we do a normalized difference formula. We use a normalized difference formula. Red, subtract by green, divide by red, add green. So this is a normalized index as well. There's the normal visualization parameters and how we present it, and then we add the layer. That's how it looks. You can see all of them gives a reddish brown color for the water. The deeper or the more the water is, the darker the red. This is quite interesting here. I just want to quickly have a look at something, because there is some definite areas in the river where there's sandbanks. So for example, yeah, here's a sandbank there. That's a familiar sandbank, which is, I got stuck in the sandbank. Okay, so I got stuck in. So if we take the satellite, I know I'm digressing a little bit. Bear with me. So you can see there's a sandbank there, especially low tide. There's a big sandbank there. That's a sandbank there. If I go up the river, There's big sandbanks here. Yeah, that one there. And then there's a sandbank there. I know these sandbanks, I've hit them many times with my boat, especially low tide. And the problem, these sandbank shifts. They keep on shifting. They're not stable. Um, so let's have a look and see. So this one actually indicates that sandbanks quite well. It indicates those sandbanks quite well. So again, this indicates water. The darker the colors of the water is, or the darker the color is within the water, the deeper the water is. Um, Meaning it's not very shallow, it's not very clear. Anyway, it's just something that I wanted to check for myself more than anything else. Let's have a look and see in terms of our bigger picture. In terms of our bigger picture, just have a look and see. There's our urban areas, there's our bare soils. It's a little lighter than this area, so maybe, who knows? We'll see. But anyway, this is called the green chlorophyll index. Okay, what's the next one? This is also a vegetation index. Well, they're all vegetation indexes, by the way. Green chlorophyll is what's in the leaves of the the plant's vegetation itself. Okay, so next one, enhanced vegetation index is the enhanced vegetation index. Enhanced vegetation. Look again. Most vegetation indexes has red and near infrared. Okay, it's got red, but it's got green. This is chlorophyll. Okay, so this is enhanced, red, and near. This actually brings in the blue band. It actually brings in the blue band. And then again, it's got a fairly sophisticated formula. Fairly sophisticated formula. Where you multiply by 2.5, divide by this, you multiply by 6, you multiply by 7, you add 1, etc., etc. So this is an even more, call it, lack of a better word, sophisticated version of the normalized difference vegetation index. Remember, we had the soil index, which was the evolution of the NDVI, and now we have the EVI, which is also evolution of the NDVI. Again, the same bands, except it adds the blue band, and then it basically uses a much more sophisticated formula. And the formula is basically just fine-tuning the whole thing. Okay, it's just fine-tuning the whole thing. So this is the EVI, and I know, okay, let's see how the EVI, I know that a lot of research actually shows that the EVI is not much better, is better, not in terms of vegetation, but the health of vegetation. It's a better measurement of the health of vegetation. Okay, and you can see there, this is a golf course, and that is soccer fields and rugby fields, and you can see it is much more green than the bare soils areas. So this is a good index. So the greener, the higher the mass, or the healthier the vegetation. As I said, the EVI is in general widely used and are preferred than the NDVI, but it's still possible to use the two together. EVI. Okay, so that's the EVI. Red band, near infrared band, blue band. Fairly sophisticated formula, and I assume they started with a formula and they just manipulated and adapted these numbers so that it becomes better and better and better to modify it. So I'm sure one can play around with these numbers. We don't have to use them. We can play around for your particular region of interest. But yeah, that's something that everybody can do by him or herself. Okay. Let's have a look and see what's our next one is the green normalized difference vegetation index. The green normalized NDVI, the green NDVI. Now you see what's starting to happen here. It's the same as with the build-up, is that we're running out of names for these things. So you just keep on spinning and spinning um, the name, changing the names, the, 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 the letters around and things like that. So this is called the green. So it's the green and the near infrared. So it replaces the red, which is band 4, with the green. And then it's still a normalized index. And it's a normalized index. Let's have a look and see how that looks like. Let's go back to the map. See how that looks. Okay, so here we sit. There's our green normalized difference vegetation index, which is again evolution of our NDVI. Still the normalized difference formula, except we have the green band and not the red band. And this is the same. And there it sits. Let's have a look and see. Enhanced vegetation index. You can see there's some difference. But again, you can't use this visualization parameters as a gauge, because here we have black, white, and green. And in here with enhanced, we had purple, white, and green. Okay, so here actually should be purple, so that we can just compare the two. So that's the green normalized difference index. Green normalized difference index. The last one that we've done, and again, this is the last one in my range, but there's many more, is what we call the modified soil adjusted vegetation index. The modified. Now, this is quite a formula. There is the formula. 2 times near infrared plus 1 minus the square of 2 times near infrared plus 1 multiplied by 2 minus 8 times near infrared minus R, all this stuff divided by 2. So you first do, remember now you have to apply BODMAS. Now you have to be clear in applying BODMAS. And I've broken mine into various parts just to make sure that I don't run into BODMAS issues. So I first created this part, which is the near infrared multiplied by 2, add the 1, and this whole thing multiplied by 2. So that's part 1, which is this part. Then I did part 2, which is this part, the near infrared minus the red times the 8, which is near infrared subtract by the red multiply by the 8. So that's my part 2. So this is part 1, this is part 2. Then I take part 1, okay, which is this part, and I subtract it from part 2, and I get the square root. Remember, the square root is a square root of all those things. If you look at the brackets, the square root is of this part here. So it's part 1 minus part 2. I get a value and then I square root it. Okay, and then I've got that value there. Then I've got 2 times near infrared plus 1 minus then this whole value, which is this part here. Near infrared multiplied times 2, okay, plus 1, add the 1, and then I subtract part 3, which is the square root of this whole thing. And then I've got this whole thing, and this is which then a part 4, and I divide it by 2. Okay, so this is a fairly complex equation within Earth Engine, and that's why I said my suggestion is to break it up into smaller bits and then expand on my equation. Okay, and then I have my visualization parameters, and I just let's see how that looks like. Eventually, that's how that one looks like. That's how this one looks like. Let's go a little bit out. That's how it looks like. So this is called the Modified Soil Adjusted Vegetation Index. Now, you can see it's basically all whites and greens. The blue is the water, etc. You can see there's some, the mountains are indicated there. Again, it doesn't really differentiate between urban areas. If I zoom in, there's my urban area, and the soil, bare soils, is both green. This white areas are heavy vegetation. These white areas, because that's the soccer fields, that's a golf course. This is that natural vegetation that's next to this bare soil areas. So this is called the Modified Soil Adjusted Index. Now there is a equation function within Google Earth Engine, where you can just put in this equation and it will generate the image. You don't have to break it up. That's maybe something that I will look a little bit later. Is to say, look, this is if it's just one or two bands normalized equation, it's fairly straightforward. It's nothing much to do. But in this case, this is quite a difficult formula to do in Earth Engine, in my mind anyway. And therefore, ideally, you want to just express it like this. You don't want to do all this stuff. Yeah, so we can look at that. And that's the Modified Soil Adjusted Vegetation Index. Okay, as I said, we've done 1, 2, 3, 4, 5, 6 of them now. And they are all, as I said, somehow evolved or related to our normalized difference vegetation index. They're all somehow related to our normalized difference vegetation index. Okay, they just basically spillovers or derivatives of that one day. And they have specific focus areas. Okay, they are there for specific reasons. But I'm using it for my own personal reason, and that is to see whether they can aid me in this quest of mine to generate an index or indexes or image where I only present my urban build-up areas with as minimum bare soils as possible. So that's my ultimate goal. Okay, so in this case, we've done quite a bit of indices, predominantly build-up or urban area indexes and vegetation-related indexes. That's the two, and as I said, a whole lot of them. Yeah, so that is generating those ones. And I said I've only presented them. We haven't played around with optimization of their visualizations by generating minimum and maximum values. We didn't do any thresholding. We didn't play around with the colors, etc., etc. It's just to show you there is these indexes and what they are, and the makeup of those indexes, the bands meaning that they require, the equations, and a basic presentation of it. That was the purpose of this particular video tutorial. Okay, as they say. Thank you very much. Thanks for joining me on this journey of remote sensing. I trust it's as fruitful for you as it is for me. I really thoroughly enjoying this series, and I look forward to having you on board for the remainder of this journey, which is still many long time from now. We still have a long way to go. Please remember to like and subscribe and to share the video. Your support means the world to me. It makes me want to go further and faster. It really helps me and motivates me. And then stay tuned. I will see you on the other side.